we're going to work on organizing and displaying data. And basically what this is going to be is reading graphs. And so if you're a very experienced graph reader, as far as different types of graphs, then this shouldn't be too difficult for you today. And there's a bunch of examples. There's actually 6 different examples, but most of them are just whether you can read a graph correctly or not, and looking at the different types of graphs and reading them correctly. So the first one we're going to look at is a bar graph. And a bar graph can be 2 different ways. They can be horizontal, like this one is, or they can be vertical. Now tomorrow we're going to talk about histograms. And histograms are a type of a bar graph, but with some different specific things about them. And tomorrow we're going to be making bar graphs and also stem and leaf plots tomorrow. So if you remember what those are, and also a box and whiskers plots. Okay, but today we're just going to read them. So here's a bar graph, and our first thing is we're just going to, like I said, we're going to basically look at reading these graphs. So this is just a blown up picture. This one says which casserole was ordered the most. Okay, and so we look for the one that has the longest bar, and so that would be what? Lasagna. Okay? All right? I told you it was going to be tough. All right? Letter B, about how many total orders were placed. Okay? Now it gets a little bit trickier here, being able to read them. And one of the things is sometimes when you're reading graphs, you have to approximate. And when you approximate, you do the best you can. Okay? It's not going to be perfect. So if we look at tuna noodle casserole, it looks like there's probably about how many there? Okay, so let's see. Here, the bar ends here, so if I go down here, then it's a little bit more than 45, right? It's about halfway between those 2 lines. Okay? And each line here represents how many? 10, all right? So we've probably got about 30 or 45 here. All right? And what about the King Ranch casserole? How many think there is there? Let's see. It's not quite halfway, is it? Or about halfway there? All right. So we can say there's probably pretty close to like 33 of them. Right? So the one thing to remember is that when you, in situations like this, you're going to be approximate. Okay? And you might not have the exact value when you are basically guessing where it is. Okay? And so when you do that, you just have to be careful and know that when I'm done, all right, my answer is probably not going to be exactly the same as what the book says, all right, but it's probably going to be close. All right? It may not be the same as your neighbor, okay, but it should be reasonably close. All right, since I've got 5 different categories here, and some of them I'm going to be able to have exact ones, and other ones I'm not. So you should probably be within 5 of each other then when you're all said and done. You would figure. Okay? All right, so this one here, I'd say there's probably about 18 there. Probably about the same here, 28. 10 more. And this one, thank goodness, that's an easy one. That's 60. So then we just add them up. And we would get what number then? Megan, you add them up for me? 184 different orders. All right, letter C asks about how many more tuna noodle casseroles were ordered than King Ranch casseroles. And according to the numbers that we chose, it would be, okay, all right, there would be 12 orders more. Okay. Now, we need this answer here for B because then letter D asks us about what % of total orders were baked ziti. So Lucas, how do I find the percent of orders that were baked ZD? How do you find it? Okay, we know there's 18 baked ZD orders. Good try. Not exactly. Okay. All right. He says we're going to take, because there's 18 baked ZD, and so he wants to take 0.18 times 60. Okay. All right. Not exactly. All right. How do I find the percent of orders then, Sarah? Okay. So we want how many of that item, how many baked ZD there were, divided by the total. So this would be 18 over 184, which is approximately 10%, right? Okay, it's 1/10 or 10%. So if I was using my calculator, (18) divided by 184, and then we change that to a decimal. So it's approximately 10%, right? 9.7% or approximately 10. Right? All right, a double bar graph. Okay, so this one is similar to what we just looked at, but it's called a double bar graph. And a double bar graph can be used to compare two data sets. It has a key to distinguish between the two sets of data. So sometimes it's harder to read them. Let's make this a little bit bigger. Take a picture of it. Okay, so what's the dark one? Dark lines represent? Okay, all right. So we have two different SUVs here, and X and Y. The darker line represents X. The lighter one represents Y. So which feature received the same satisfaction rating for each SUV? Okay, so we're looking at what? Where the bars are the same, right? So that would be cargo. Which one had a better gas mileage rating? So we find the mileage. All right, the lighter colored one here has the higher bar, so that would be SUVY. Okay, a line graph, or I like to think of these as what's called a plot over time. All right, it displays data using line segments. The line graphs are a good way to display data that changes over a period of time. So sometimes they're called plots over time because of that. This is when you graph your grades, okay, this is exactly what you're making, all right, is a line graph or a plot over time. So you should be, when you do that on Monday, should connect them, make sure they're connected. Look at that. There's the answers. All right, forgot they were there. Okay, so at what time was the humidity the lowest? Can you guys see that good enough or not? Should I make it bigger? Okay. All right, what time was the humidity the lowest? And RJ, when would that be?
4 a.m.
Okay, 4 a.m. And during which period of time did the humidity increase the most? So CJ, what are we looking for? Okay, so from 12 p.m. to 4 p.m. Okay, you guys all agree with that? Some people do. All right. Who doesn't agree with that? Okay, we got a couple people that don't. All right, Eric, why don't you agree? Okay, all right, so you're talking about from here to here. So is it higher from 8 a.m. to noon or from noon to 4 p.m.? Okay, but we're going to look at just at one period of time here then, okay? From either 8 to noon or noon to 4 p.m. Okay, noon to 4, okay? You guys agree with that? Okay, now what am I really looking for then in this case? Okay, the steepest. I'm looking to see where the line is the steepest. Now here's the thing. All right, let's use our horizontal line here just for a second again to see if we can. Okay. So if I take and look at this horizontal line here, all right, and this looks like what's the percent there at noon? Okay. The percent at noon looks like it's about 45, right? Okay. At 8, come on. All right. At 8 a.m. it was 40. At noon, would we say that's 45, or does that look like less than 45? Okay, this is where we need to know. Okay, is that 44 or is it 45? Okay, because if there's a difference, right? Because if it's 44, then going to here would be 5 units or 5%. Right? But if it's 45, then going from here to here is only 4. Okay? So sometimes you need to take a real good close look at that, and they're both very close to each other, right? And without exact values, we might not be exact here, right? Hopefully in most problems you'd see there'd be a little bit bigger gap to make it difference between them to make it easier to read. All right? Okay, so from noon to 4 p.m., we're looking for the steepest slope. Good. Double line graph can be used to compare how two related data sets change over time. Double line graph has a key to distinguish between the two sets of data. All right, so the darker lines here are station A, and the circle ones, so we have the triangles are station A, the circles are station B. Prices for gasoline. Look at those prices for gasoline.
I wish they were like that.
Yeah. Okay. They definitely are not that right now, but at least they're not $3 to $3.50 to $4. So, I wish they'd stop fluctuating. You know what? Put it at $2.49 and leave it there. I don't care if it goes back down to $2. Just, you know what? Stop being so fickle. Right? What's that? And make the Russian government fall. Yeah, all because of the price of gasoline. Helped. Okay. All right. Which month did Station A charge more than Station B? Miss Patton? So let's see. Let's go through this. So we got January, February, March, April, May, June, July, August, September, October, November, December. All right. So which one? So we're looking for when Station A is bigger than Station B, so the diamonds are bigger than the circles. Right. I know it's harder to see. Oh, charge more. Yep. Okay. All right. So that would be May. Because here we've got the diamonds are above the circle, okay, the dots. Right? During which months did the stations charge the same for gasoline? Which months are they the same? Which ones? July. All right, so June, July, so that would be here. Okay, anywhere else? No? In April. So in April here. All right, good. Any others? Okay, so April and July, they charge the same price because $1.26 in April and it looks like about $1.29 in July. Okay. All right. Man, that would be nice. Okay. All right, circle graphs. They show parts of a whole. The entire circle represents 100% of the data, and each sector represents a percent of the total. Circle graphs are good for comparing each category of data to the whole set. Okay, so in this circle graph here, we have a punch recipe. Any of your parents ever make punch? All right. We make this punch at our house that involves sherbet and like 7-Up or Sprite, usually 7-Up, and then we use Hawaiian Punch in it as the other ingredient, and that's one of our favorite holiday drinks. And no, there's no other ingredients in it. It's just those. Okay. We don't add anything else. Okay. All right. So, which ingredients are present in equal amounts? Okay. So, which sectors look like they're the same size then? All right, Paige, which ones appear to be the same size? Okay, the lemon sherbet and the pineapple juice have the same amount in them. I might have to try this recipe. It's kind of like some of those newfangled water concoctions that people come up with. They throw a bunch of vegetables or fruits and stuff in just a bottle of water, or to have a little bit flavored water. I haven't tried any of them. I need to try them. I mean, how many of you go drink lemon water? You get water at a restaurant and you put lemon in it. Probably a lot of people do. I do. All right, which ingredient makes up half the volume of the punch? All right. Definitely orange juice. Okay. All right. Good old ginger ale. All right. Do your parents give you ginger ale when you don't feel good?
Yeah.
Hmm? No. Okay. All right. Very fizzy. Okay. All right. That's right. That's what it is. Vernors. All right. We're almost there. One more. Okay. Choosing and creating an appropriate display. Okay. So here you're actually going to make some. Okay. And all I'm going to do is I'm just going to go through the examples that are in the book so you know why. And so when you get to the questions where they ask you what kind of graph should I make and ask you to make it, then you need to use the examples from number 6 to be able to determine that. Okay? And they all have specifics, and I've highlighted them. Okay? All right, so here they give us a livestock show entries. All right, how many of you show animals at the fair? Anybody? Nobody in here? Okay. All right. So they show the different livestock. You got chicken, goat, horse, pig, and sheep, and how many different entries there are. Okay. And the question is, all right, what kind of graph should I use? And we're going to use a bar graph whenever we are going to compare categories. Okay? Since we're comparing how many different entries there are for each of those categories, then we would make a bar graph for that. And so we would list the categories, chicken, goat, horse, pig, and sheep, make a vertical scale that would be appropriate, okay, and draw our bars above them. Okay, so if we're going to compare categories, we'll use a bar graph. Letter B says division of crops. Right? So we have corn, fallow, mixed vegetables, soybeans, and wheat. And how many acres there are of all of them. Okay? A circle graph is appropriate because we're comparing the parts of the whole. Parts of a whole. Could I also use a bar graph for this one? And it kind of depends on the questions they're asking. Okay? But if I am going to do the division of crops, that would be in a pie chart or a circle graph, because I want to be able to see each sector and how big they are. Okay. Letter C, we have students enrolled in Shinnick College and the year. Well, anytime you see years and numbers that go along with them, you're always going to use a line graph or a plot over time for that. That's the most appropriate because we're going to show the change of what happens over time. And that's it, just those three. Okay, so here we have graph. Says the data below shows how Vera spends her time during a typical 5-day week during the school year. So which of those graphs would probably be best in this situation? A bar graph, a circle graph, or a plot over time or a line graph? Okay. CJ says a bar graph. Why, CJ? You got to explain why. Why? So what are we looking at here? We are looking at, what do we call these different things? Okay, they're categories. So we're going to compare categories. So the amount of time on each category. So that would be a bar graph then for that. Okay. All right, for comparing categories, a bar graph. All right.